Oh, itu sudah, Pak. Coba saya cek di YouTube ya.
Iya,
Masuk.
ya, sudah.
Heeh.
Saya sudah.
Pak
Coba.
Seno cek di HP. Saya coba cek di HP.
Iya, iya.
Pasca Sarjana IPS. Oh iya, Pak. Oke, Pak. Sudah masuk, Pak.
Ya. Pemutaran lagu-lagu.
Pak Seno,
Ya,
Mbak Vika tolong dijadikan co-host.
oke.
Pak Seno. Ya. Mbak Vika tolong dijadikan co-host. Aduh, suaranya di...
Mantul.
Mbak Vika yang bagian putar video ya? Halo?
Halo,
Mbak Vika.
bukan Mbak,
Yang putar
yang
video ya?
putar video Hasna.
Kenapa? Halo?
Yang putar video Hasna.
Halo. Oh, Mbak Hasna belum masuk ya?
Belum, masih Vika hubungi Mbak.
Yang putar video Hasna. Mbak Hasna mana ya? Belum masuk ya? Pak Seno?
Ya,
Iya, tadi saya share video kelihatan nggak ya?
kelihatan. Tapi nggak ada audionya.
Oh, nggak ada audionya. Oh, berarti kita nunggu Hasna aja kalau gitu.
Sudah, Mbak. Mohon saya dijadikan co-host, Mbak.
Oke, Pak Seno minta tolong Hasna jadikan co-host.
Ya.
Hasna putar video ya, di saya nggak bisa audionya.
Baik, Mbak.
Surabaya, the provincial capital of East Java, is the second largest city in Indonesia. This city has a huge number of diversities among the people, cultures, and ways of living. Surabaya has been acknowledged for its green public open spaces. It also has successfully equalized the development between build-up area and green area that makes Surabaya a livable city for all.
I see Surabaya as a great city with amazing people.
Living pace here is quite slow, so you don't feel the rush of living in the city.
It's also a good place to travel around. I mean, in bus you can go in many places, or taking train on Java.
It makes me so to be in peace, so I think that is a good place for me to stay.
Surabaya is also known as the City of Heroes because of its role in Indonesian struggle for independence. Moreover, Surabaya nowadays has already become the center of businesses, commerce, industries, and education in Indonesia. One of the pioneers of education in Surabaya is the Institute Teknologi Sepeluna Pemba, better known as ITS. ITS has 3 campuses in Surabaya. ITS Sukolelo as main campus. ITS Manyar its campus vocational study of civil infrastructure engineering. ITS Jokro Aminoto as campus for Master of Management Technology. Occupying a large area of 180 hectares as its main campus. ITS has 20,000 students, 1,000 academic staff, 1,000 non-academic staff, 10 faculties, and 38 departments. ITS has various fields of study, faculties, and strategic study program which are the center of excellence. Faculty of Industrial Technology, Faculty of Marine Technology, Faculty of Electrical Technology, Faculty of Civil, Environmental, and Geoengineering. Faculty of Business and Management Technology. Faculty of Architecture, Design and Planning. Faculty of Information and Communication Technology. Faculty of Mathematics, Computing, and Data Science. Faculty of Natural Science. Faculty of Vocational Studies. Study program at ITS consists of vocational program, bachelor program, master program, and doctoral program. ITS also has more than 130 full-time international students and 400 international student mobility short program, K&B program, student exchange, and another programs.
I work with many projects and many assignments, so it's helped me to improve my personal skill and also for communication skill.
There are many things that we have to fulfill, and ITS has been helping me to improve this kind of things. Beside my hard skill, I also have been able to develop my soft skill, which is important for nowadays leadership.
Also with ITS, I had a lot of opportunities to join different events for free, like the Rujak Connect Festival, which was the cooking event, something. Yeah, this is like kind of opportunities that you don't have every day, and it's funny to take part for once. Yeah, it's nice.
ITS inventing many technological innovations that have been acknowledged in various international competitions. These are several national and international achievements by ITS. ITS Central Library is in a 6-story building, with total building area 9,000 meters square. This library, more than 121,000 printed textbooks, more than 10,000 e-books, 10,000 audio-visual data, and 18,000 digital library collections. Besides providing students with the books, the library also provides students with comfort study area, like discussion area, hotspot cafe, computer rent, multi-purposes room, and Indonesia Development Information Services, which connect to the World Bank database. Research and innovation at ITS are geared towards addressing global challenges.
Distinguished guests, ladies and gentlemen, before we start commence the program, and here are the following webinar protocol. For each participant ID, please use your real name following with your origin of institution. All of participants are expected to mute the audio and only unmute the video during the event. We cordially invite you to take your own firm and comfort seat in your own room, and please avoid the backlight. Make sure that you have a good and stable internet connection. If you have an earphone or headset, we recommend you to use it so that your voice can clearly and loudly to be heard. During the Q&A discussion session, all participants, please use the chat box to deliver the questions. Thank you for your cooperation and consideration.
Assalamualaikum warahmatullahi wabarakatuh. Good evening, ladies and gentlemen. Thank you for joining our researcher and research student enrichment program today. Before we start our agenda, let me reinform the webinar protocol to join this event. First, please adjust your name or ID screen using the given format on the slide. Second, during the event, please turn off your audio and only turn on the audio when the moderator gives you the chance. Third, please turn on your camera. Fourth, ensure your network has a stable connection. And fifth, adjust the seat position comfortably and prevent the backlight effect. I will also read out the important information for today. First, please fill in the attendance form on the link bit.ly/attendance_R2SEP 2021. The link will be closed in 15 minutes on 3:45 GMT +7. Second, please fill in the feedback form that will be shared 15 minutes before the session ends, and it will be closed after 1 hour. Third, the attendance and feedback is compulsory for this process. First, mandatory attendance for ITS masters and doctoral students new intake, and then it's for certificate of participation, and it's eligible for international participants who have 60% attendance or minimal 5 meetings. And then third, for STEM for it, and it's eligible for ITS undergraduate students. Welcome to Researcher and Research Student Enrichment Session on today, Thursday, the 29th of April 2021. I am Nur from ITS Global Engagement, and I will be your master of ceremony for this session. Please do not forget to fill your attendance at the link bit.ly/attendance_R2SEP 2021 that will be sent by our committee via the Zoom chat room, and the link will be closed in 15 minutes from now. Participants who wish to ask questions during the question and answer session, please send your question at the link bit.ly/science_Q&A_R2SEP 2021 that also be sent by our committee via the Zoom chat room. Alternatively, you can raise your hand during the Q&A session to ask your question directly. Before we start our agenda, allow me to deliver our schedule today as follows. For the first agenda is the opening, and then continued by the second agenda, which is the introduction of the moderator and the speaker. After that will be the main agenda or the lecture session, followed by the Q&A session, and will be continued by the certificate awarding. Finally, followed by the last agenda, that is the closing of R2SEP. Before we move on to the next agenda, please allow me to elaborate about today's lecture. Today's lecture theme in the sciences stream of R2SEP is about common research methodology in your field, which will be delivered by our speaker, Dr. Muzafar Zulkifli from University Kuala Lumpur, and Dr. Azzah Pramata from ITS will be the one conducting today's session as our moderator. Our moderator today, Dr. Azzah Pramata, is a lecturer at Materials and Metallurgical Engineering Department in ITS. Dr. Azzah finished her bachelor degree in chemical engineering at ITS, her master degree in chemical engineering at ITS and Kumamoto University in Applied Chemistry and Biochemistry Department, and also finished her PhD in Applied Chemistry and Biochemistry in Kumamoto University. Her research interests include synthesis of nanomaterials and quantum dots, and their application for solar cell, energy storage, and antimicrobial agents. Now that you are informed about our moderator, without further ado, let's proceed to the main agenda. To Dr. Azzah as our moderator, the time is yours.
Okay, thank you very much, Ms. Noor, for the brief introduction. So good evening, ladies and gentlemen. Welcome again to the Research and Research Student Enrichment Program. I am Azzah Pramata, and it is my pleasure to be a moderator for this session on the topic of common research methodology and in your field. I'm sorry. So the flow of this session will be another sharing session following with Q&A and also discussion for 30 minutes. And in this session, we will gain knowledge about how to build your research methodology, start from determining the suitable method of your research, the type of the data that you may need, how to get them, and how to process that data so it can be a publishable data. We also will get information regarding the strategy to raising project grant. Okay, before we jump to our session, may I briefly introduce to you all our guest speaker from University Kuala Lumpur, Malaysia. He received master's degree from Birmingham University and received PhD from University Kuala Lumpur in 2018. His specialty is on advanced polymer materials, and with that, he made impactful contribution in the development of medical appliances, oil extraction, and also waste and water treatment. He has a distinguished academic and professional performance. He is appointed as ATAC panel and a certified trainer for TTT from 2020 until now. And he was also a deputy dean of International, Industrial and Institutional Partnership University Kuala Lumpur Malaysian Institute of Chemical and Bioengineering Technology. So everyone, please welcome Dr. Muzafar Zulkifli. Dr. Muzafar Zulkifli, the floor is now yours.
Okay. Assalamualaikum and salam Ramadan. Good evening, can say. It's already afternoon. Thank you for having me in this research and research student enrichment program. I would like to say welcome to aspiring postgraduate students as well as researchers that is here. My name is Muzafar. I will basically share today what me and my team has been done in the last 3 to 4 years. And hopefully this sharing session will at least give you some idea and enlightening enough for you to get some idea on research methodology that I will share from my field and from my point of view. Okay, so this is, So this is basically the presentation outline for my presentation today. I will do a little bit of introduction, around 5 minutes, about my workplace, where I am basically exercising my research activity in University Kuala Lumpur. And I will also focus a little bit about the University Kuala Lumpur MISEC, Malaysia Institute of Chemical and Bioengineering Technology in Melaka, where our chemical engineering campus is. Then I will also talk about the research cluster that I have, our team, and the postgraduate students that is currently with me and my team. We talk about the Directorate of Experts, which actually will be a very vital element in making sure that my postgraduate students will have access to all the needed expertise for them to have no problem or any stumbling block in doing their research. And we'll also talk about the list of projects that is currently ongoing. Also, next, we will be talking about some fundamentals on research methods and research methodologies, the differences that is there, which I will be focusing more on the projects that I'll be doing, that I'm currently doing, looking at the types of research methodologies involved. I will try not to give lectures today because lectures you can actually get it from your campuses and from your postgraduate schools. So in this sharing session, I really hope I can at least enlighten you to the right way of looking things, from how your supervisors, co-supervisors way of looking things in terms of what is it that they want you to do, and you need to know what kind of research that is basically you are doing in order for you to do things easier in the long run. And then when I look at the type of research methodologies involved later, we will also be explaining to you, based on the selected project, what are the research methodology will look like when you do your project later, when you carry out your research later. As we outlined, research methodologies cannot run away from sampling and data management. Here, we will also be talking about the type of samplings that I've been doing for my project, which my student has been carrying out. And later, we talk about the types of data management that will also be involved. And last but not least, later, in order to service the projects, because if you're talking about 3 or 4 projects running in concurrently, if you have your supervisor managing 3 to 7 postgraduate students, in order for those projects to run smoothly, you cannot run away from the fact that money is always a factor. So we would like to advise aspiring young researchers who actually become lecturers later to focus on this particular part, getting the grants, so that your project will not gonna have any problems, which actually will go on into conclusion and recommendation. A little bit about University Kuala Lumpur. University Kuala Lumpur is a very young university. We are talking about 18 years. A university that is 18 years. We are a private university in Malaysia. Nothing like ITS, because ITS was established in 1957. In Malaysia, if you're talking about a university that is as mature as ITS, you're talking about UiTM, which was incepted in 1956. But University Kuala Lumpur, as I mentioned just now, is just 18 years of age, and we have 14 different institutes all over Malaysia. And the one that I am currently belong to is Malaysia Institute of Chemical and Bioengineering Technology in Malacca, and my team focuses more the area of research that me and my team is basically looking at is polymer and environmental engineering technology. Basically, my team belongs to Green Chemistry and Technology Cluster, University Kuala Lumpur, myself. About University Kuala Lumpur, for those in Indonesia, I think in Malaysia, people are quite well aware of the university itself. The advertisement is everywhere, in a way. Even though it's one university, it is actually scattered all over Malaysia. We have 139 programs and over 24,000 students. Produces 31,661 graduates in the last 16 years. The skill of trade for this particular university is hands-on. Something like I think ITS is currently championing in Indonesia, whereby we are focusing more on 60 to 70% hands-on experience with very high lab-intensive learning activity compared to 30% classroom activities. When we say we are scattered all over Malaysia, if you can see this particular slide, we scattered all over Malaysia. We have a lot of faculties in Kuala Lumpur area, in Melaka, in Johor, we have in Perak, and we have one in Kedah as well. The area of specialization that we have, if talking about chemical and bioengineering technology, polymer environment that I am currently practicing is in Unique MySet, as you can see here. Unique MySet. If you're talking about automotive, is in.
Tolong boleh tanya Pak Dosen.
Ya, ada.
Okay. So we have our specialization all around the country, mostly engineering technology and engineering approach for University Kuala Lumpur. This is basically our campus. We are heavy in terms of laboratory in Melaka. We have 37 laboratories for chemical engineering, duplicate and triplicates we have here. So in terms of facility, we are quite there compared to the renowned universities in Malaysia. We're talking about Melaka, we focus on food technology, environmental technology, bioengineering technology, process technology, as well as polymer technology. And we have plenty of center of excellence and research clusters under UNIKL, and I belong to this Green Chemistry and Sustainable Engineering Technology Lab. Okay. And from where I am, the research group that I am basically with in Melaka, we have the principal researchers that looks into our projects, Dr. Amanaim, TSAP, Associate Professor Dr. Amanaim, me myself, and Associate Professor Dr. Abbas, who is a renowned statistician in Malaysia. I have one postdoc, and currently we have four PhD students under us, and we have 7 master students, with one recently completed in the last 3 years. For our small group of research group, we have research collaborators from USM, from Palestine, UITM, as well as PSU in Thailand, Prince Songkla University. We have industry collaborators as well from Malaysia Rubber Board for my study in latex antimicrobial glove. We have collaborators from Plastic Rubber Institute, Malaysian Plastic Manufacturer Association, as well as Gramtech, Sudan Berhad. And if you're talking about international collaboration, we have working relationship with National Institute of Tiruchirappalli in India, as well as Prince of Songkla University. I would actually have to highlight here the directive of expert and expertise that I have, that currently my team is having. We have me and Dr. Hakima from University of Malaysia Police, who looks into polymer. We have a microbiology expert with Malaysia Rubber Board, who helps me with my antimicrobial glove studies. We have 3 lecturers who look at environmental based projects. Dr. Manaim, my postdoc, Dr. Hamida, as Dr. Salim from, right now he is with University in Palestine. We have Dr. Wan Manso, Professor Wan Manso, who actually is working with me in 3D printing filament, natural fiber based and conductive based, graphene based. As for now, we have experts in chemistry in helping us to make sure that our problems in chemistry are being taken care of. If you're talking about qualitative studies, we also do have expert from business school in University Kuala Lumpur, so Professor Abdul Razak Hadi, who help us in qualitative studies with regard to turnover problems in oil and gas industry. We have with us a colloid scientist, a renowned colloid scientist, second ranking in Malaysia, Dr. Manoj Chansing, to help us with the latex industry. We have Dr. Cyril from Unical MyTech on electronic and electronic signaling process. We have advanced material people from Unical Miat and UTM who help us in terms of composite, and all will actually be focusing back to Dr. AP Abbas, because at the end of the day, the research that currently we are going through in the direction now will always go back to statistics in order to do screening, modeling, validation, and optimization. That is basically how the research is as for now. So in terms of accessibility, we have the manpower, we have the people, and all the projects that we do, usually we will make sure that our students will have the best access to the best brains in the industry, in the academic industry, so that we will not have any stumbling block when we do our projects and coming up with the best of papers possible, Q1 until Q4. So these are the projects that is currently being taken up. We have composite projects, we have lipid extraction by using supercritical fluid extraction. We have candlewood nut extraction process as well. We have thermoset recycling for PhD, and then we have laminate, wood laminate products studies. We have pyrolysis from waste tires. We have this Mr. Sharin Waram, who is currently doing the qualitative studies in terms of turnover scenarios. We have Azzah Shafiqah, who is currently producing beads for as bioabsorbent for heavy metals. We have one student who is currently doing studies on producing latex glove with antimicrobial properties. And we have a student who is currently doing leachate studies using statistical modeling. Okay, so in terms of things running for the last 2 or 3 years is quite a number that is currently ongoing, because these are just there to make sure that we will be supplemented for the next 1 or 2 years. Then we go back to what we are supposed to look at today in terms of research method versus research methodology. When you talk about research method, usually you just mentioning about experiments, tests, and surveys. It can be anything under the sun. So when you've already identified what is the kind of experiment that is needed for your research, you already look at the first point of literature survey, you do your background check on studies on what has already been done in your area. You've already identified the research gap, you've already come up with your hypothesis, problem statement is already there, and you look at what is it that people has already done. You will see there are many experiments, tests, and surveys that is available. And in our case, usually we will have to make sure that the research methodology, the techniques that you need to choose is the correct technique and must be at least in line or at par or the current practice that is already there in the market. Okay, and when you have these two combined together and the technique is correct, when you have the standard and you have the method that is clear through the right methodology, then it is the work plan for any research that is going to be easy. In simple word, you're trying to find a solution to the problem that is the main target of the research method itself. While the research methodology is the employment of adopting the correct procedure. So this technique must always be correct for us to reach out to the right answer. So we really hope when you have the right research method, the research methodology will show the right way for the research method to be applied correctly to get the best of result. If you're talking about any scientific or non-scientific research, you're talking about research methodology will always come in the beginning, whereas the research method will always be at the end. Okay, in order to obtain a perfect outcome of the research, you need to be good in terms of research method and research methodology. And then, if you're talking about the type of research methodology involved, my team, if you're talking about the type of research methodology involved, there are a lot of research methodology types that is available. We talk about basic research, we talk about applied research, we talk about problem-based research, we talk about problem solving, qualitative or quantitative. But usually for me and my team, our approach is very simple. We don't want to make things complicated. You either go for basic research or applied research. You see, in my case, in my team case, for University Kuala Lumpur, we do around 40% scientific research and around 60% engineering-based research. So if you're talking about basic research, usually we do to get more towards using fundamental principle in collecting data to enhance whatever knowledge that is possible. And usually for this kind of research, basic research is usually theoretical research, which actually try to provide in-depth and systematic insight to a subject to make the scientific and logical explanation viable. For basic research, usually at the end of the day, you will provide adequate and minimal data analysis, which is actually good enough for master's or PhD studies. And if you're talking about applied research, we talk about solving practical problems, which actually requires scientific methods to be incorporated. And we try to solve problems that is already known and based on proven theories. And usually we talk about applied research will involve kinetics, modeling, validation, and optimization. It doesn't mean that in basic research we don't actually apply that, but usually in basic research, for me and my team, we don't really want to make things too complicated for basic research. As long as you can get enough data from the tests and from the experiments that you get, if you do minimal or manual Excel calculation, it's already good enough. But if you're talking about applied research and the kinetic, the modeling, validation, and optimization will always come into place. And if you're talking about applied research plus, in our opinion, applied research plus will usually involve a higher level of involvement of student and staff, which actually will involve designing, prototyping, simulation process as well. When we talk about applied research, usually here is where the statistics will come into the picture. Okay. With me explaining to you that these are the two types of research that we involve, I will try to make it more interesting and more understanding by sharing the projects that we are doing. The first project is basically this is a composite project. We try to prepare polypropylene and kernel fiber, as well as polypropylene kernel fiber with silica, nano silica infused in the pores. We have our objectives here. I have 4 objectives that we have here, as well as the second project, the preparation and characterization of polyaniline in natural rubber latex article to make sure that they are antimicrobial and conductive. That is basically what we would like to do. The objective study is there. So for the first project, if you're talking about the methodology, if you allow me to divulge in the methodology, we prepare the kernel fiber based on the selected particle size, and then we try to optimize And then we want to make sure that this kena fiber is to be subjected to salt gel process for silica. And we try to optimize the silica modification by making sure that the variables is controlled. And when we've already managed to optimize the formation of silica inside the fiber, then we will actually do the sample preparation of the kena fiber with silica with the polypropylene using compounding process using the twin screw extruder. It's basically my field. And when you already have the kena fiber polypropylene with silica, then you proceed with doing the testing. And when you do the testing by looking at whatever that I have here, I don't really, for this particular project, I don't really need any statistical tool in getting the optimized condition of the product because it's basically a straightforward research itself. From all the input that I have from the mechanical test, the thermal test, the morphological test, as well as analytical test, from there I can actually make a good result analysis, straightforward result analysis to get what is the best formulation available. But when you do your methodology testing, when you prepare your methodology, you must make sure that the methodology reflect the objectives that you come up with. It must at least, for all the objectives that you've already outlined, it must already cover all the objectives so that you can actually proceed to the next part in result and methodology, sorry, result and discussion. If that is not to be considered done, then actually you will start to have a lot of problems when you do your writing in the later stages. I think for most of the time for students, the real problem is when you come up with the flowchart of your methodology, when you carry out the experiments, right after you've gathered all the data and the sampling is done, you gather all the data. When you want to write, you get to know that there are certain elements of the writing is not there because the data is being omitted. You missed one or two important information that makes the flow of the thesis going to be a little hiccup here and there. So this is actually a good practice that you can do whenever that you come up with your methodology flowchart. Do a revision with your supervisor from time to time. Make sure that it tackles the objectives that you have. When you have this, I'm very sure it's going to be easier for you when you do your writing later. Same goes if I would like to highlight here for the second project just now, the latex and conductive latex project. For this particular project, if you're talking about the flowchart, first, the students will have to distill the aniline to get the best of purity, and you do the polymerization of pani with different molar ratio. Make sure that you do the analytical test to make sure that the molar ratio, which molar ratio will give the best amount of percentage of polymerization you can get from the pani, polyaniline. And from there, you can prepare the sampling of the pani together with whatever materials that you want to add inside your pani to make sure that you have a hybrid filler. So when you have that, you must also make sure that you do all the testing required to quantify and to qualify that this pani is being prepared enough. When you have done that, when you've gotten the best and optimized condition of the pani templates as what we call as filler in the latex that you want to form your glove for the second P2 project, then only you will start to cast the filler inside your PV latex, pre-vulcanized latex. So this kind of project is quite straightforward project. You don't really have to involve a lot of variables that is going to be quite tedious if you're talking about different kind of project. So once you start doing the casting of the latex, you will do your thermal test, mechanical test, and electrical conductivity test. And then once you've gotten all the result, do the antimicrobial test, and then you get your result analysis. So by looking at this P2 methodology for project 2, objective 1 and 3 is being covered for the upper part, for the earlier part of the project, and objective 2 and 4 is already been covered for the lower part of the project. So that is basically for, if you're talking about, that is basically for basic research. And if you're talking about applied research, I also enclose here 2 projects that we are looking at, specifically to look at projects which actually involve statistical approach. The third project, which actually falls under the applied research methodology, is statistical modeling for enhancing the biodegradation of stabilized leachate via persulfate oxidation process. Okay, we have here 4 objectives of the study. And project number 4, we have magnetic cellulose chitosan composite hydrogel beads. We make beads from these 4 materials as bioabsorbent for heavy metals. Okay, that is project number 4. Let's have a look at how the flowchart of the methodology will look like. So as you can see here, this is for the project number 3, the methodology we have. We have the leachate sampling, and then we pre-characterize the leachate sampling according to the 11 parameters we have. This is an environmental project, and then you use a persulfate oscillation when you determine the dosage, optimum dosage, determination of optimum pH, and determining the optimum retention time. Of course, you will need to do your screening, and then you will need to do treatment by the factors that we have here is persulfate alone, persulfate with zinc, persulfate with tannin. And basically the parameter we're looking at are the COD, color, ammonia, and TSS value. And then after that, you talk about post-characterization of the leachate, as well as the statistical analysis using multivariate statistical analysis, as well as experimental design. See, if you try to have a look at this particular project itself, there are a lot of variables that you look at. In order for you to do a straightforward project like basic research just now, like the first 2 projects, is quite impossible because there are a lot of factors that will actually have to come into the research. So the best method is for you to go with the statistical approach technique. Because once you got the first result, you can always do the screening. Right after the screening, then you can actually choose what are the variables that you would like to choose as a control in order for you to make sure that you get optimized condition and optimized result for your project. And by doing this, the first part of the project on objective 1 and objective 2 is already being covered for this particular project. And after we've done with the statistical analysis, then objective 3 and 4 will come into the picture. Hence, we make sure that a project of this complicated nature will actually be taken care of with the statistical approach, will make things easier for everyone. If you're talking about project number 4 just now, we make beads, as you can see, for the methodology. We talk about 5 different phases that we have here. This is also environmental study. Sorry, excuse me, please. For phase 1, the study, control study, we have the method is to synthesize the magnetic cellulose alginate hydrogel beads by sol-gel process. We also need to synthesize the magnetic chitosan alginate hydrogel beads by sol-gel itself, and characterization and absorption test of the beads. And then we proceed to phase 2, the development of bioabsorbent by using sol-gel method, the CCMA. And this is being done to achieve the specific target of objective 1. And you talk about the phase 3, right after you've done with phase 2, phase 3 is absorption capacity of the heavy metal is to be studied we look at the batch absorption of the CCMA on heavy metals, copper, plumbum, and chromium. And after we've done that, we will see whether we already achieved the specific objective or not for objective 2. And in objective 3, since in phase 4, we will have to study the absorption kinetic and isotope study. This is basically to make sure that whatever outcome that we get from phase 1, phase 2, and phase 3 is tally with the kinetic study, then the isotope study itself. So this is actually, if you're talking about this particular project, this is done by my counterpart, by our counterpart in the chemistry part, because they are the expert in this particular area. Right after objective 3 is done, in phase 5, the next study is for desorption and reusability study. And here we regeneration of the bits by using HTL and determination the reusability cycle of the CMMA itself, which actually will tackle objective 3 and 4. Okay. So what I would like to highlight here is you can have everything under the sun, the best definition of research method, research methodology, whatnot. But you have to make sure that you put it on paper. And when you put on paper, you must be able to see whether the notion of whether it serves the need of the objective is there or not. It doesn't matter if the project is quite straightforward project as a basic research project, or an applied project with quite complicated and a lot of variables to look at, as long as you make sure that the approach is taken care nicely on the flowchart basis, review with your supervisor from time to time. If the objective is taken care of, then actually your project will not actually having any problems in the long run. Okay, we would also like to, this I just would like to share. We also, as the project tells, we have candle nut and sewage sludge that we try to extract the lipids from it, and then we fractionize, and then we do characterization and yield characterization, and we do the trans-esterification process, so that at the end of the day we will have yield characterization that we can actually use in a biofuel. For this kind of project, you can actually go with basic research or applied research approach. If you're talking about using more variables than whatnot, especially in terms of using extraction process, then most probably the best way for you to go is to make sure that you have a statistical tool to look into getting the best parameters that you should look at. There are parameters that you should log, and there are parameters that you should actually free. Then it's going to be easier. You can also just, if you're talking about a master's level project, if you don't really need to look into the details of the parameters, you can always go with the basic research approach. And for our waste tire pyrolysis, we just make sure that we get our waste tires, do characterization using TGA, DTG for proximate and ultimate analysis. We use a fixed bed reactor as a pyrolysis unit. We look at 4 different parameters. Here for PhD, we incorporate the statistical approach for this particular research. But for masters, we look at these 4 parameters, and at the end of the day, we can still get the pyrolysis all. And when you do the characterization, you can actually get the product, and we blend with conventional diesel for characterization. This project is already finished as far as I'm concerned. The student is already graduated, and the approach is accepted because it's quite a straightforward project. So in terms of type of research, for my team, it's quite straightforward that we have already try to simplify things. So in terms, if you are talking about an approach from a case study, from a real project, this is basically the best way to go. From our understanding, if we do it this way, then it will make things easier and more clearer for the students to proceed in their research. Next, I would like to talk about sampling. Okay. There are various types of sampling that is available. is already been given. If you can see here, simple random sampling, you have cluster sampling, okay, probability sampling method, systematic sampling, stratified random sampling, and whatnot. But in in the case of my group, research group, we only focus on systematic sampling approach because it's the best for scientific approach, and cluster samplings are also preferred for quantitative studies. So these are the only two sampling method that we look at. Okay, just would like to share with you, these are the sampling visits that we have. On the website, sorry about that. For the sampling visits, as you can see, this is where we got our latex samples from. This is where we get our leachate from. Okay, and this is basically where the Malaysian Rubber Board is for us to get our samples and do our testing done. Just to share with you, if you're talking about sampling, for the first project, we talk about preparation of and characterization of soldier silica modified kenaf bus fiber polypropylene composite. You talk about sampling, it's quite straightforward project, it's quite a straightforward sampling process. We procure the sample from somewhere, and in terms of sample preparation, it's quite a straightforward lab to lab process where we get our sample from point A to point B without actually having to do any other specific modification or any specific treatment to the material itself. So in terms of sampling, whatever that we got, we prepare it in the form of compounding. And at the end of the day, we have like 7 different types of compound. For each compound, we have like 1 to 2 kilograms. Make them into dog bone shape sample or flexural shape of sample. And then we do a destructive test, mechanical, thermal test, and we get the result. So it's very straightforward. You don't really have to do a cluster different kind of sampling. And another example that I would like to share is for project number 3, that is basically using experimental design, material and methods. For sampling here, we're talking about 20 liter of sample that you get from rubber wastewater from industry, you get from the glove manufacturing company. And from there, you will have to do sampling in the lab for characterization and analysis. As the process is quite straightforward. And later, we also incorporate the experimental design to make sure that the process is going to make things easier, to be stringent. The screening process is there as well. Okay. That is for sampling. And next, we talk about type of data that is involved for our project. You see, there are 7 different types of data that is offered for research methodologies. You have qualitative, you have quantitative data, you have categorical data, you have observational data as well. You have experimental data, you have simulation and derived or compiled data. In our case, qualitative and quantitative data is there, but usually we are talking about experimental data. And for this experimental data, if needed, we would actually go towards derived or compiled data. So in my group's projects, we're talking about qualitative variables and quantitative variable data. So for qualitative variables, for the turnover project with business school, we will actually have to look at the possibility of looking how emotional impact have on the COVID scenario for workers who are no longer being given chance to work with the company. But for quantitative variables, is there for you to see. We have experimental data all along from project 1 until project 4, as for example. Yes, this is basically the current project that is being done, study on turnover scenario in oil and gas companies in the pandemic time, which is actually using the qualitative data. So a little note on the quantitative data analysis that we have. For project 1 and 2, as earlier, the data that we get, we focus them on the descriptive analysis, which actually will look at simple statistical approach on as means, median, mode, percentage, frequency, and range. Okay, the first level of analysis. And if you're talking about projects of nature of project 3 and project 4, we talk about inferential analysis, which shows complex analysis where relationship of multiple variables will actually come into picture to generate results and make predictions, where correlation, regression, and analysis of variance will actually be important. In this case, if we're talking about descriptive analysis, usually I will just ask students to use Excel for as the statistical software. Sometimes they also would like to use Minitab. I have no problem with that. But if you're talking about project 3 and project 4 nature, usually the university will advise students, or my team, Professor Abbas, will advise students to go with free statistical software, or like SAS, or you can also use JMP, Design Expert if you're talking about design of experiment. You talk about RSM, you talk about Minitab, MATLAB if you're talking about ANOVA, R, SPSS as well. So the statistical tool that is to be looked at is either simple p-test, t-test, R-squared, ANOVA, or design of experiment itself. So if you're talking about the type of data that we look at, especially for project 3, this is a paper that we already published. Because of the project itself, we look at a lot of influential factors. A factors is zinc sulfate dosage, pH, reaction time, and mixing ratio. And the responses we are looking at also TSS, COD, color, POD as well, ammonia, ferrum, copper, plumbum, and zinc. So here the raw data of the 30 experiment that we have, in order for us to do the screening and making sure that we take care of the factors, we have to do FCCCD, the face-centered composite design, and look at using ANOVA, the independent variables, the factors, and corresponding levels used for the optimization of rubber wastewater treatment is basically we summarize in the paper itself. At the end of the day, what we get is a 3-dimensional response surface curve and their effect on the responses, as I mentioned just now. And we also make sure that the interaction curve show the behavior of 2 factors on the effect of the responses as well. So when you have the data, you need to make sure that you know and you have the right person to guide you in making sure that the data becomes useful. I'm not an avid fan of asking students to go and learn themselves about using statistical tool. For me, in order for you to be a good student, in order for you to be a good postgraduate student, you need to have a good you need to have a good supervisor or co-supervisor in helping. In our case, in my group's case, it's going to be easier because we have Professor Dr. Abbas, because usually he will be taking care of this particular part and making sure that the correct advice and correct guideline is to be given for the student for that particular project. And if we're talking about data to be used for project 2, this one we are talking about the latex glove with antimicrobial properties now. The data is to be manipulated in a way that is very straightforward project. You perform the test, you get the numerical data, and the numerical data, because the number is not in abundance, you get to simplify the data, you put it in the table, and once you put it in the table, you can get which one is basically giving you the best. Even though it looks like a simple table, it looks like a simple project, but we already managed to publish it in Q1 to Q4 papers in the right approach. It doesn't mean that if you have a project that is too simplified, the data that you have cannot be published in a good TED journal. It doesn't work that way. So just now I've already talked about research type, sampling, and the data that we have on how basically you can manipulate and use that particular data. In order for us to make sure that these projects can be carried out for postgraduate students as well as for lecturers that is around, there's no two way about it. It is the responsibility and it's the decorum of the lecturers to get the best of grants that is available around you. For university grant, institute grants, or national grants. If you can get international grant, it will be better, because usually around you, you will have a lot of good projects, but without money, a lot of testings are deemed quite impossible to do. And I just would like to highlight here, if for postgraduate students who aspire to become a lecturer in the long run, become a researcher in a research institute in the long run, or for the lecturers who are available, I can only give a guideline about what is basically being done in Malaysia. Whether you like it or not, all grants will actually tie up. If you're talking about national grant, it will always tie up to the areas and to the areas where the government is actually looking at, interest of government. For in Malaysia, if you apply fundamental research grant, if you apply excellent research grant, usually you will have to make sure that you are well versed with 12 national key result area. What are the interests of the nation? You have to also look at the Sustainable Development Goal, the 17 points of the Sustainable Development Goal. And whether you like it or not, 2030 Wawasan Kemakmuran Bersama should at least be something that you can relate with. Because as far as I'm concerned, these are the grants that is currently the team is having under University Kuala Lumpur. We have somewhat around more than 600,000 grants, even though the amount is small, but it's good enough to make sure that all the students have stipend. They can pay for their fees from the stipend as well. And you have enough money. If happens that if you're talking about your institute doesn't have that particular testing, very specialized testing, like in my campus, we don't really have a specialized expert in microimaging as well as antimicrobial microbiologists. So I will actually have to rely on expertise from outside, and they are not cheap. And the best is for you to have grants, and there's no other way. You have to make sure that the grant is basically available. You have to get the grants first and then get students, and that's basically how you get your research to be smooth at the end of the day. If not, you will have a lot of stumbling block in the research. Okay, so basically that is those are the things that I would like to share with you with regard with research methodology. I know my method is not conventional. I don't give lectures. I just sharing session with what we've been doing. I would like to leave you guys with these two comic strip that I got from the internet. Sorry, I didn't put the citation there, sorry. As you can see here, if you look at the first comic strip, there was a conversation between the guy and the lady there, talking about the way I feel is hard to quantify, and the response from the lady is how hard on the scale of 1 to 10. Point being is, yeah, you can read 10 books on how to conduct this, how to be a good postgraduate student, how to be, how to write your thesis, how to write thesis in 10 days. I don't know. There's a lot of things going on out there. But then again, it's a matter of you doing it, and try to make sure that you go through mistakes. You will not learn unless you make mistakes. And you are only being given, if you're talking about GOT, 2 years to make sure that you do mistake first and make sure you do the correct thing later. By reading books will not make you move in your research. You will have to do it and experience it. With that, then only you will get to know which is the right way, which is wrong. And we talk about the other comic strip. If you can see, any professor, any trainer will give you the best philosophical answer for everything. But for people like me, doers, it doesn't make sense. For me, if you're talking about research methodologies, you will actually have to experience doing it. Then you will understand what actually is research methodology is all about. And make sure you side with the right people, with the right supervisors, and if possible, make sure that you have, your research team has the right people and right sources to help you with your studies. This battle, you cannot do it yourself. You will have to rely on people around you to help you to go through this battle. There's no two way about it. Okay, thank you very much. I hope you enjoy my sharing is now, and salam Ramadan. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Muzafar, for very interesting talk, and it gives us new insight about the research methodology. So now I open the floor for Q&A and also discussion. If anyone has any questions, I'm sure Dr. Muzafar here would be very pleased to answer them. So the participants who wish to ask the question, you can raise your hand or you can type your question in the chat box. Okay. Yeah, we'll check the link first. Okay, anyone here want to ask about how to build the research methodology? Okay, Dr. Muzafar, let me ask you one question, maybe. So if we are in the earlier stage of our research, let's say I'm the first year of master student or the first year on PhD students, and then the topics were given by our supervisor. So we have to learn from zero about the research that we are going to do. So what should we do first if we are in that situation to design the suitable research methodology?
Interesting question there, Dr. Azzah. This is usually the problem that we have with our surrounding. I mean, usually if you are talking about a research that you have not been through, you've not gone through, you've never heard before, and this is the first time you will actually be involving yourself in this particular field, especially maybe you have heard it during your undergraduate time, but you have not come across any material or read any scientific report on that particular matter, it is always difficult. Give yourself a head start by trying to read as many referee material in 1 month's time. Usually, I will ask my student to read for 1 month time. If they have not come across that particular area of interest, area of research, and right after 1 month time, usually you will have some general idea what is it all about. And I always advise students to always go back to the supervisor and try to talk and try to communicate with the supervisor, try to explain to the supervisor to see whether your understanding is matching with what the supervisor expect. You need to know where you stand in this particular time frame. Usually, if in 1 month time you are stuck, then you will actually have to get help from either your supervisor or your colleagues around you. Reading itself will not help much if you don't really have the basics. And in terms of research methodologies, I think nowadays it's going to be easier because reading materials are, how to say, quite accessibility is easier. Those days when I did my masters in the UK, if I cannot get access to the area of interest, the papers, because of the limitation of access, I would have to wait for the librarian to get the papers. It will actually take 1 or 2 weeks time before I can get the paper. But now, yeah, I don't recommend Science Hub, but I guess anything that will help you save time, you should be able to use. But then again, I don't see any problem as for now for you to get access to information, and it will help a lot.
Yeah, of course. Just in the tip of our finger, just click.
Yes.
We find what we're looking for. Okay, so basically you have to understand what we want to do first. Correct, Dr.
Yep.
Okay, so we move on to the first question from the participant. The question is from Putra Erfirdaus. Question is, if there is a research that we want to do, yet there's no method for such experiment yet. Maybe it's a novel method, no one has done it yet. And we must invent a new method. How we express it in our research report. Especially since most research is based from the already existing method. Maybe he want to develop a new method, so he wonder how to express that new method.
Okay. Okay, correct me if I'm wrong. I think as far as my experience supervising and assessing Viva student, I have not come across a project that requires a totally new method. If you're talking about like in my case, when I did my PhD, I'm trying to infuse silica, synthesis my silica inside the void of Knaf. And you know the void of Knaf itself is almost submicron. Okay? So in order for me to infuse the silica into the void of the Knaf, I will need to make sure that my precursor, the starting material for my silica, is in liquid. At that time, when I did my PhD, there was nobody has ever done that. I mean, nobody has ever done, people has already infused nano silica inside the void, fine. But I want to generate in the lab my own silica. I want to synthesize the silica itself, and I can control the size of formation of the silica. So in different field, there might have already been people doing something like that for any research. So usually this kind of research is just adapt and adopt. If you're talking about a totally new method, no existing method before, that will actually be a little bit hard. Usually, I think modifying from other methods is normal, but to come up with a totally novel method that people has never done, you're talking about centering, I don't know, if you're talking about extruding, if in my area, if you're talking about materials, like Dr. Azzah area, semiconductor, that process itself is whether you adapt and adopt from different material. That is usually what happens. If you're talking about a totally non-existing method, I have not come across. If Dr. Azzah also have any idea on that, because for me, everything is adapt and adopt.
Yeah, okay, I agree with Dr. Muzafar. I never come across with a totally new method that never existed before. So it comes with adapt and adopt, modified here and there. So it's becoming like modified a method from which original method, like that. So as long as we are under the sun right now, there is no really new method, because everyone already developed the method. So we just adapt and adopt everything. Yeah, I think as far as I know, and correct me if I'm wrong, Dr. Muzafar, so I never come across with a totally new method. We just like adopt from some existing method and we modify, so we can get a better result. Yeah.
Agree with that.
Okay. Okay, thank you very much. Any more questions from Mr. Putra? Yeah, so it's just the modification, adapt and adopt on the existing method. So we got a better method. It's just a better method and improvement. Okay, thank you very much, Dr. Muzafar. And the next question, if we want to do a quantitative research, which one is more suitable, inductive method or deductive one? Inductive. If we want to do some quantitative research, quantitative, not qualitative one, so which one is more suitable, the method, inductive research or deductive research?
Okay.
Sure. Yeah.
Question is valid. If you're talking about inductive method, that actually depends on the data that you plan to have. Okay, the data that you plan to have should actually be able to tell you which is the way forward. If not, then usually you'll be having a lot of problems there. I would prefer to go inductive method, honestly speaking. Don't ask me why, but if I'm talking to my student, I would actually ask him to do the inductive method first.
Inductive research is better. So I'm not sure about the question comes from, because he or she didn't write her name here. So hopefully Dr. Muzafar already answered your question. So we proceed to the next question, Dr. Muzafar. How to create a novel methodology with suite to data problems? For example, structural bricks economics, especially in non-parametric forecasting method. I think it's, yeah, maybe it's about how to create a novel methodology suitable for our problem.
Okay, it goes back to the first question that we have just now. Because talking about novel method, if you're talking about real novelty, if you're talking about research methodology, is something that is already established and you actually try to do some modification. Yeah, I cannot come across any way that you have totally novel method of doing things for methodology.
How about the novel method for the humaniora or social topics, research topics, such as how to break structural economics or how to maybe how to improve the our country economics, like that, in social research maybe, or management topics.
Okay. To be fair to the person who asked the question, I might actually have to get back to you. I might have to refer back to Professor Azzah, my counterpart for the business, in order for you to get the right and correct decision on that. But for the sake of today's discussion, for me, as long as you have data, once you have the data, then you know which way that you want to look at after this. I give you a simple example. In our research that we have in our group, we decided to use Cronbach Alpha method to do the questionnaire. The thing is, when you talk about Cronbach Alpha, you need minimum number of company participating is around 7. And we're talking about 23 companies in oil and gas in Malacca region to see how is the pandemic affecting their operation in terms of turnover business. But to get the 23 companies to commit on a student's project is almost impossible. The HR keep on turning us down, citing the fact that they have more important things and more urgent things to do. So actually it hinders the progress of student. Whether you like it or not, for you to move, then you will actually have to consider different kind of method to proceed. Which actually brings me back to my point is, you need, before you decide on what to do next, you need to know what kind of data that you can actually have present to you, makes it easier. And for God's sake, this is a master or PhD project. Please don't make it too complicated for the student, especially. If it's too difficult to achieve, then actually it beats the purpose of the learning process altogether.
Okay, thank you very much. So we give back the question. The question was from Yoga Sasmita. The answer entertained you enough?
Which one is it? Sorry.
Yoga Sasmita. The last question regarding the how to analyze the structural bricks economics is from Yoga Sasmita.
Okay, Ms. Yoga Sasmita, I think if you can contact me personally, I will try to find the answer for you later. I don't really have that answer for you.
And also, if we are dealing with existing method, because basically no novel method in today's situation. So what is your advice for this situation to avoid duplicating or plagiarism?
Okay, I need to really understand when you say duplicating of method. You see, when you do your research gap analysis, it's not the method that you're looking at. Usually, if you're talking about the subject matter that you are doing, maybe the material, different material that you are actually looking at. If you're looking at different material, and if the methodology is basically almost the same, you will get different result. For sure, you will get different result that you will need to interpret and you need to justify why your result is like that. And the beauty about your finding later, you can always compare to the research that you are referring with without actually having to worry about duplicating or plagiarism at all. It's quite straightforward. So if the method is the same, let's say if you're talking about manufacturing a car, company A manufacture using this particular method, company B is actually manufacturing using the same method. But when company B is basically using different materials to manufacture the car, the outcome is not going to be the same as the company A. So your finding is basically something that you will need to describe. So that particular method have no issue here. For me, it's quite straightforward. And sometimes, usually your methods will not be 100% the same with other research, because your supervisor will have his or her preference based on their skill that they would like to add to the research to bring value. That is something that we as academicians, as researchers, have instilled in us. We always want to make sure there's not to say specialty, there's always a novelty in a way in the research. Because it's easier for us to defend at the end of the day because we are expert in that particular area. If not, if we just follow or duplicate whatever is already there, then sometimes when you want to describe the finding, it's going to be difficult because that's not the area of expertise of us.
Okay, Dr. Muzafar, can we say that the research methodology is a way to get or to achieve what we want or our target in our research objective? Can we say that? So it's just the way so we can build novelty from our result or from our input. Can we say like that, Dr. Muzafar?
Okay, I would like to share with you my experience when I did my PhD. My supervisor at that time, Professor Azzah, he's in Michael, currently the Deputy President. When he sit down with me at that time, when we started discussing about me doing the project, first and foremost, he asked me, okay, this particular project, show me how you're going to do it. So I explained to him these are the route and the tests and the ways of me of doing or of making sure that I carry out the project. When he sees that it's doable, he asked me to look for reference material that actually shows this project is doable. Then he asked me to carry on with the project. Whether you like it or not, the heart of the research is the methodology. You get your methodology correct, usually you will not have any problem because the literature review part and the discussion part, if your methodology is solid, then the writing, the flow is going to be nice. If not, you will stop. I cannot imagine yourself doing PhD in your third going to fourth year, doing your writing. When you do your writing, suddenly you realize that you need to prepare sample back to do SEM and TGA. That will require you 6 months of work, extra 6 months. If that happens, usually that is basically why students start to give up with their project. So make sure the methodology is solid, then inshallah, I think the research is going to be quite straightforward.
Okay, thank you very much, Dr. Muzafar, for the very informative answer. So for the next question, okay, maybe this is from me because I always get the same question from the students. Like because here in Indonesia, we are very, how can I say? It's just a very hard to find the analysis apparatus such as SEM, even XRD, or any analysis apparatus. So we have to take we take time for almost 1 month until 4 months just for waiting list for the analysis. So if that happens, so of course we will lose that time a lot. If we are do the procedural like Dr. Muzafar shown to us before, right? We have to confirm A, B, C first, so we can move forward to the next confirmation. So if we do that, we sure that we will consume a lot of time. So if we do that in parallel, is it okay? So from A while confirming B, confirming B and confirming the other parameters?
For me, as long as it doesn't involve screening, then it's okay. If it involves screening, if you skip the step, then usually you will not get the finalized answer whether you should drop that sample A, B, C, or continue with D, E, F. That is basically why, actually, if you're talking about testing, analyzing, and using all these equipments that is deemed very difficult to use due to queue, I have to go back to my last point just now. You need to have money, because for me, I cannot wait, because I am working with people from other universities, other institute, where the KPI is to make sure that we get as much papers published as possible. So in order for me to make sure that the tight timeline is served, I usually will send my sample to private organization or private company, like for SEM especially. I know they are a bit expensive, but that's the way forward, because if you allow the university's problem, for me, it's a university's problem with all this queuing to hinder your progress, you will be left behind, honestly speaking.
Yeah, maybe that's most of students in Indonesia maybe facing the same problem. So we have to queuing for analysis because of the equipment. Even if we send to other university or other institution, it will be the same condition.
Yeah, Dr. Azzah, I just would like to share with you, during these COVID times, I have been sending, I think every week I have been sending samples outside to do testing, because here in Malaysia, movement is a bit restricted for different states. So if I want to go to KL, it's going to be quite a hassle for me to go to KL for my student to send samples. So what we do, we always courier samples out there to individual labs, to companies with all these testing equipment, and I will usually get the result back in 1 or 2 weeks time maximum. And I think that's the best way forward lah. If you are talking about waiting for the university's facility, like SEM, for sure you have to queue around 3 to 4 weeks. Then usually work will not be done.
Yeah, that's maybe most of students here facing that kind of problem, especially during COVID-19. Because here, I'm not sure, because I just come back from Japan, but I'm not sure if we have like independent or private owned like laboratory for analysis. I'm not sure that we have that, because as far as I know, that even the industrial or some producer, some manufacturer, they are sent their sample to us.
University, okay.
Yeah, so that's quite a problem here.
So like, okay, sorry, Dr. Azzah, sorry, I just would like to highlight as well here. Like in Malaysia, one of the biggest supplier for SEM is Hitachi. I think in Indonesia also the same, right? So we end up sending samples to them, and they charge us quite a hefty amount of money to get the sample analyzed. And for me, it's a blessing in disguise, because whether you like it or not, it's fall on the prerogative of the lecturer to find solution. If not, if the student will actually have to wait for 3 to 4 weeks to get the result done, then you can start saying bye-bye to GOT, honestly speaking.
Yeah, that's quite a problem here. Yeah, so yeah, it's great that Malaysia doesn't face the same problem with us. I open another question.
Dikunci loh. Stop gitu.
I'm very sorry.
Sorry, Dr. Azzah, if you allow me to share on one experience of mine with everyone here. Okay, to all, I just would like to highlight here that I've been with UNIKL for 18 years, but I started my research career in the last 3 years. I have been an administrator with UNIKL for the last 15 years. I've been the deputy dean, I've been here and there with responsibilities. So I totally neglect the research part, the academic accolades I totally neglect. So in the last 3 years, when I focus my energy and my strategy on gathering the best and correct mind to be with me on this particular journey, in the last 3 years, I already managed to publish 6 Q1 papers, 4 or 5 Q2s, and a lot more papers going up. So I just would like to tell you guys, it's never too late. I am already 42, quite late for me to start, not as young as Dr. Azzah. Okay, but it is never too late for everyone to actually indulge yourself in this area. What I've done in the 3 years, sometimes I wonder if I would have actually spent my thoughts earlier, 10 years back, I would have actually been somebody right now, a professor maybe right now. So in the 3 years also, I already managed to get to this point. I'm very sure any of you, if you start now, you will get it. It's just a matter of planning it and making sure that you have the right mindset to move forward. Okay.
Yeah, thank you very much, Dr. Muzafar, for the inspiration. Hopefully it can wake up our motivation and for the students here and for the researcher here. Okay. So thank you very much, Dr. Muzafar, for the insightful speak. So here, let me conclude about our discussion. Okay, about our discussion. So actually, your methodology is the heart of your research. So make sure that it's solid and it's organized and clear and concise so you can get the reliable data for your research. Okay, thank you very much, Dr. Muzafar. So thank you very much also for ladies and gentlemen. May I thank you for your participation, for your very active participation. And I look forward to seeing you in the next webinar RSEP. Okay, thank you very much. I give the floor back to Ms. Nur Azizah.
Okay, thank you very much, Dr. Azzah, for conducting this amazing session. Also, thank you very much to Dr. Muzafar for the excellent lecture today. Okay, furthermore, we would like to present a certificate for our honorable speaker and moderator. Okay, so maybe the operator, please help me. Okay. Okay, so this is the certificate presented for Dr. Muzafar Zulkifli. Thank you very much, Dr. Muzafar.
Yeah, thank you.
Okay, and then the next one is for Dr. Azzah Pramata. Thank you very much, Dr. Azzah. Okay, please everyone give applause to Dr. Muzafar and Dr. Azzah by using the Zoom reaction feature for today's amazing session. Okay, furthermore, once again, thank you very much to our speaker and moderator for your availability on today's session. Okay, before we end today's session, we invite you all participants as well as the honorable speaker and moderator to take a group photo. So please, for the participant, you may open your camera. Okay, here I see 7 slides. Maybe I will start counting when some of you have opened your camera. Okay, I will wait for a little while. Okay. Okay, maybe. Okay, for a little bit. Wow. Okay, then it's okay already. I will start capturing my screen. Okay, 3, 2, 1. 3, 2. Okay, please wait. I have 6 slides here. The 4th slide, the 5th slide, and the last slide. Okay, thank you very much, everyone. Then for the participants, please fill the feedback form through the link bit.ly/feedback at SEP 2021 that you can also see in the Zoom chat room. And we want to remind you the participant who will get the stamp for it is the participant who come on time, join this event until the end, and also fill the feedback form. Finally, we have reached the end of today's Researcher and Research Student Enrichment Program, and we sincerely apologize for any mistakes that we may have made in presenting as Master of Ceremony and the committee. Thank you very much to all speaker, moderator, and all participants for the attention and cooperation. Before we part, I would like to inform you that we still have several future agendas in R2SEP for Science stream. You can see it on the poster we are showing you after this. Also, maybe you want to see it on the ITS Global Engagement website later. We will see you in the next session on the 20th of May 2021 with the theme Research Management Skills that will be delivered by Dr. Ma A. Beltran from Tarlac Agricultural University. As always, at 3:30 p.m. GMT +7. Once again, thank you everyone for today. Good evening and wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Muzafar, for your time.
Okay, thank you, Dr. Azzah. Thank you, committee. Thank you, everybody. Assalamualaikum.
Waalaikumsalam. I will give it back to you.
Waalaikumsalam.
Okay, so maybe everyone you can leave as the host will close this meeting later, I think. Okay. Goodbye, everyone. Thank you very much.